Understanding the effects of corona discharge in electrical power systems. By engineer Jean Paul. In the world of high-voltage engineering, some of the most dangerous threats are not explosive or loud. They are silent, gradual, and often invisible. One of these is the corona discharge, a phenomenon that many engineers are aware of, yet its impact is sometimes underestimated until failure occurs. In this article, I want to walk you through what corona discharge really is, how it affects electrical systems, and what we can do to minimize its damage. What is corona discharge? Corona discharge is a localized ionization of air that occurs when the electric field strength around a conductor exceeds a certain threshold. This usually happens in high-voltage systems, especially around sharp edges, loose connections, damaged insulators, or points with concentrated electrical stress. When air molecules get ionized, they release a faint glow, usually bluish, a crackling sound, and sometimes an ozone-like smell. This process may seem minor at first, but over time, it leads to serious consequences. The real-world effects of corona. Let's break down the key impacts of corona on electrical systems. 1. Degradation of insulation. Corona continuously attacks insulation surfaces. The ionized air reacts with materials like PVC, epoxy, or even ceramic, breaking them down chemically. This leads to cracks and tracking on the insulation surface, reduction in dielectric strength, premature failure of cables, bushings, and other HV components. 2. Power losses. Every corona discharge wastes energy. While the loss per event is small, it adds up, especially in long transmission lines or substations where corona occurs frequently. This not only reduces system efficiency but also increases operating costs. 3. Interference with communication systems. Corona emits a broad spectrum of radio frequency noise, which can interfere with telecommunication lines, SCADA and control signals, wireless systems near substations. This is a serious issue for industrial environments where signal clarity is critical. 4. Production of ozone and nitric oxides. The byproducts of corona, like O3 and NOx, are chemically aggressive. These gases can corrode nearby metal surfaces, react with moisture to form nitric acid, which further damages equipment, harm the health of technicians working in close proximity over time. 5. Initiation of partial discharge and arc formation. Corona is often a precursor to partial discharge, PD, a localized dielectric breakdown that occurs within or on insulation. Over time, PD can lead to full flashovers or arc faults, which are dangerous and costly. What causes corona to appear? Corona discharge is more likely to happen under these conditions: high voltages, above 11 kV, and poor conductor surface quality, sharp edges or non-uniform fields on terminals, dirty or wet insulators, especially during rainy seasons, loose electrical connections in panels and terminations. Understanding these causes helps in prevention. Mitigating the corona effect. Engineers and technicians can take several steps to prevent or reduce corona in systems. Design with smooth and rounded conductors to reduce electric field concentration. Use corona-resistant insulation materials, especially in harsh environments. Install corona rings or grating rings on bushings and HV terminals to evenly distribute the field. Ensure proper spacing and clearances in busbars and cable terminations. Conduct regular inspections using thermal imaging, ultrasonic sensors, or UV cameras to detect early corona activity. Keep equipment clean, especially insulators exposed to dust, humidity, or industrial pollution. Final reflections. Corona is not just a textbook term, it's a real, physical phenomenon that silently erodes the lifespan and safety of high-voltage systems. I've seen cases where multi-million franc equipment failed due to long-ignored corona damage that started with a faint hiss or glow. As professionals in electrical power systems, we must give corona discharge the attention it deserves, from design to maintenance. Whether you are an engineer, technician, or student, understanding and addressing corona discharge is not just good practice, it's essential for building safer and more reliable power systems. Construction worker mail sign. Let's start more conversations around power quality. insulation reliability, and preventive maintenance. Feel free to share your thoughts, or reach out if you've dealt with corona issues in the field.